Okay, as you can see, I've made some progress here. This is going to be another super short one. So I considered a number of ways of running the water and ended up with the idea that I would rather run the water north-south and have 5 stacks high and deal with it that way. Well, 6 stacks high, 5 stacks of sticks high, then bring it down the side here and have more width. So I packed all this together and I used a little bit of a blueprint to get these bumps. So the water, each one of these has the same layout, comes across, goes up and goes across. So they kind of build. You can see how I could have started off with just this blueprint and striped it out very easily. We do that on all of them. And the same thing horizontally. We bring it in tight, and each column we bump it out one. Oops. And I didn't finish pruning him. But you can see how I clipped that together. And I got it all out to here, and I thought, how am I going to connect it up to that? And I looked at all sorts of different ways of doing it, and finally decided I would just take the lines up and stagger them out half and half. So this went 1, 3, 5, the next one went 2, 4, 6, and then I was just going to join them. So we end up with a little bit of an angle on these lines. There's 2 ways I could tighten this up in the future. I could, for example, take this and just bring it straight across and join up with him. I could move this jog down a little bit, so when he comes across, he would hit this level, and then over here somewhere we jog it over. So this could be tidied up. I don't think it's important to do so. We can have a little bit of a narrowing here. This isn't too bad. The angles are good. We don't have anybody overlapping. I did have to do this manually. If you bring it up and over, it wants to correct the east-west component in the verticals. So these verticals aren't vertical, and the horizontals go right along the line, and that causes overlap. So that got my water going, and I am still just barely under the height of the water tower. So I didn't have to make the water tower taller. Almost, though. And the next thing I want to do is think about the placement of the nuclear waste reprocessing. I started laying it out here. And initially I was going to put, 2 blenders and 3 assemblers and 2 manufacturers and a particle accelerator. And that's all I need for each third of this. And I thought, wait a minute. I could just put these down and route belts. I don't need to build blueprints out of it. This is not a big build. Even 6 times what's in the blueprint containers and 3 particle accelerators. I think I can just lay this down and build it. And at the end, this guy's going to be producing plutonium fuel rods, which can get synced, and they will give us a whole bunch of points. So the next question is, how am I going to route the fuel and the nuclear waste? So it would have been nice if the reactors had taken fuel in the front and put the waste out the back. Now, it would have made it very much easier to route. But I think what I'm going to do is I'm just going to clip on a vertical riser like that. And then we're going to put a merger here, since that's our output. Oh, and we're going to have to reclip the riser so it connects up. Now, if I wanted this to be closer, I'd have to put I could pull some tricks to make it closer. I'll just put it that way. But if we do, then would we be clear of the pipe? And I don't think we'd be clear of the pipe, so we'll just do it this way. In fact, I'm going to put it one further out. That is indeed the input. So that's our fuel input line. So we need a splitter. Now, I almost did a bad thing. I don't want to do a manifold of fuel, because otherwise we will end up with a tremendous amount of nuclear fuel sitting on the belt. And I would rather distribute it evenly, so we will tend to have less stuff sitting on the belt and more stuff in the reactors. Thank you, autosave. Your timing is perfect as usual. So on this elevated level, I'm going to have to put up a splitter, and I need to split. Oh, wait a minute. I almost forgot. My fuel is coming from up there. So the fuel is coming down in, and I need to have the fuel split 6 ways and come into here. So it's not my problem at this level. However, the output is. And we could just merge together the output along this line. Let's put it here. I'll worry about the routing of the input when I start thinking about the fuel rods. Now, even if I were worried about how much materials I was using, I would still use the fastest possible belts, because we really want to get our nuclear waste, which is highly radioactive, pulled out and sent over and processed as quickly as possible. So here is one line coming out of nuclear waste. As I said, I will worry about fuel routing. I may, in fact, route the fuel underneath where there's a whole bunch more room. But let's leave that TBD. If I do, it'll just be, a through hole like that, and it'll come up from below. And below, I can worry about evenly distributing all of the fuel so it lands in all of the reactors. We want to get one piece of fuel at every reactor before we send a second to anybody. So with that coming out, we're going to have 2 lines of, well, let's take a look at the recipe. Why not? And I left my editor too big, so we're going to bring it into place. And I can narrow it down like that. So nuclear waste, 1/3 nuclear waste is 2 blenders. So each blender will be half those numbers. So they'll take uranium waste. They'll also need a source of silica, nitric acid, and sulfuric acid. So it's this first column, this first thing, this first blender that needs our acids. After that, we've got 1 particle accelerator split, that is shared between two rows of reactors. We've got 3 assemblers that are shared, so there'll be 1 assembler on each side plus 1 in the middle. And we'll take the 1.5 assembler outputs and we'll send them to the manufacturers. And it's all very, very compact because reactors don't turn out waste very often. But when they do, oh, it's bad stuff. So I still haven't thought about routing of everything else. I'm going to go ahead and place a blender. These are all going to move. But I'm thinking of just doing all of my work here at ground level. Leave the under level for routing of fuel. And we see that I can route this in the far left side. So there's my 4. We can't do this in 4s anymore because the reactors are 5 by 6. Oops. Can I pick it up again? No, I can't. So 9. Oh, come on. There's the blender. So let's say I put the blender where it will just pick it right up And we've got plenty of room out here. I mean, we've got an embarrassment of room. So this may not be as short as I thought if I'm going to get into building this, but let's toss something together really super short and super quick. This is building non-fissile uranium. So I need the source of silica, nitric acid, and sulfuric acid coming in. And those will all come in from that direction. And that looks like it's enough space for me to run it. But I want more than enough space. Let's give ourselves another foundation worth. There. So if I am bringing acids in and they're shared with 5 other blenders, then I want to bring it in from the top, which means these guys are both drop-ins. So the best way for me to note that for future routing is to grab this guy and just go out here and say soup and soup. And that'll flag to me that we've got a couple of liquid inputs and we need to bring them in from above. And we have silica coming in. I just put that on a splitter. We have enough silica that I don't need to worry about evenly splitting. Silica is going to be 120 per minute per third, so this is all on one belt. So boom, it'll just come on through. Just like that. In reality, I will probably route the silica high, which means these guys go even higher, later. Okay, so blender outputs. This blender has 2 outputs. It's got some water that gets recycled and some non-fissile uranium. So it's not a lot of water. I mean, it's 15, oops, I forgot to do the overclock. This is a overclock to 240%. Let's run at 250. So we've got about 35 or 40 cubic meters of water per minute. What I'd like to do is take the water from this and feed it back into somewhere. And normally, like in the other reactor, I fed this back into the nuclear fuel preparation area, but that's going to be way, way, way over there. So what I will do instead is I will be working this into this water input right here. So we're going to put a X like this, and he needs to be the bottom. So reality, I'm going to need to do some work right here so that we have our water coming in and being the bottom line and fed in from this line on the top. Something I can work out when I'm not doing a quote quick unquote thing. So the output of this is uranium waste, is non-fissile uranium, and we want to take some fraction of it. We don't want to take the whole thing, as it turns out. Let's give ourselves some working room. Say, how about 3 of these guys? And I think I'm going to align I want to align this so that its inputs are halfway in between the 2. So it's 6 this way, so I want to go 3 in from here. So there's my edge. Oops, not blueprints. Particle accelerator, somewhere about here. We can nudge it later. And we're going to put it out. Cha. So this will share between the blender for here, and there'll be another blender over here. We will simply merge them and they'll come in here. In this case, this is building plutonium pellets. So our inputs are uranium waste and non-fissile uranium. So actuality, this is where I want to drop in and adjust this. So 3/4 of the uranium waste goes into the blender and the other quarter goes into there. So I need a splitter and a merger. And I need another splitter. So half of it goes this way, and half goes this way. And of this half of it again goes back here. So that's 3/4 going in there, and the other quarter going out this way. And this is going to be there. Like that. So this splits off our uranium waste. Now the other part is that I will be bringing this in from two sources. So let's do this right. So I need to replicate this on the second one so I can get this correct. So this is just over the line here. And this one is just over the line here. Splitter. And a splitter. And a merger. Although this splitter goes on this side this time. Okay, see what happened there? I connected that through and it connected all the way through to the wrong place. Splitter. Splitter. Just like that. We're just roughing things out. And our other input is the, so we have this, and we also have to merge the outputs of the blenders. So what I'm going to do here is I will raise this. Just like that. Now, if I were following the same rules that I set up in the larger factory, I would have selected which direction would be elevated. It would be the lines this way. No, I want to match it. So these lines this way would be on the ground level, which means that I would be elevating a lot of things unnecessarily. So let's keep things on ground level unless I need to. And this guy comes out and says, oh, we're going to go from here to here. And then I'm going to merge over here. And there will be another line coming in from the right, and I'm not going to build the other machines, but I will put a line out there saying, yo, this goes somewhere. So those together, the non-fissile uranium and the uranium waste from these two sources goes into the plutonium pellet machine, and it is overclocked to 240%. Well, I'm rounding things up in this chain, so this guy's running at 250, this guy's running at 250, so they'll be able to run just a little bit faster than steady state, just in case we build up some, which is likely because when we start, everybody's going to start roughly the same time, so we'll get a whole bunch of materials at once. And running a little faster means we will tend to drain those. What we want to do is we want to have each batch drained before the next batch hits, with a little bit of margin. So his output is plutonium pellets. And that will go into a splitter, because we're going to go back to our two-way thing. So we're going to send this back up. So now we're processing 1/6 of our total coming out this way. The next machines are these assemblers. So really what we've got is we have 3 assemblers being driven by this guy, where 2 of the assemblers are contributing to the right, 2 to the left, and the one in the middle is contributing both ways. So this becomes a little bit different. This is a normal 3-way split, which I will draw up. So let's say we want our assemblers to be anchored on these lines roughly cha. I hate the nighttime. Okay, I'm going to use a splitter to mark where this is happening, and it's just to the left of that seam. I'm going to give 1, 2, 3. And the other one is going to be similarly placed for here, just to the left of this seam. So let's put them down. These are markers. These aren't going to be used as splitters. So now we grab 3 assemblers. And this is going to be encased plutonium cells, which are going to take the plutonium pellets we just produced, and they're going to have a supply of concrete coming in as well. So I'm going to put it just right there on that edge. Like that. And then we want one in the middle. And what have we got here? 1, 2, 3, 4, 5, 6. So 1, 2, here is our marker. Just like that. And this one is not aligned. So because we want to minimize the amount of radioactive stuff, we want to bring our, I'm going to bring these guys to a splitter here. Comes in from the right, just like that. Which means our concrete is going to have to go up and over, and that's perfectly all right. We can play some games with that. And I'm not going to worry about that right now. I will, however, put that in to remind me we've got to deal with those. And this gets hooked up to here. Thank you, autosave. Your timing is perfect. And the fact that my output here is 1 meter from where it should be, once I get all of this roughed out, it's all kind of spread out and roughed out here, what I'm going to do is I'm going to start inching things into place without recording it so that it's, not sprawling. I mean, it won't be truly compact, but, not sprawling. I'll see if I can straighten those lines up. So now we have merger on each side. And a splitter in the middle. So now we're back to handling this output, which represents the results for just this row of reactors. And that should be encased plutonium cells. And there will be a similar here. So the next stage puts us through a manufacturer. And again, I'm going to give us a nice, wide, generous buffer between the two so that I can explore how to best compact this. He goes there, and he's going to go there. Just checking. See, as I compact this, I also want to watch that I'm still able to connect up nicely to the reactors. And these are plutonium fuel rods, which require the encased plutonium cells that we just made, and they've got 3 inputs coming from elsewhere. So we'll have inputs coming from here that will be picked up and put in there, those guys. With some sort of surface routing. And the output of this, what I'm going to do is I'm going to assume that I can merge all of these coming back. Well, not assume, I'm going to decide that I can merge all of them coming back. And the output of this gets tossed in an awesome sink. So this whole mechanism is going to be highly radioactive once we get running. So let's see, we need to remember that except for the first row, the merger faces this way. Okay, so that's roughed out. So the nuclear waste reprocessing is fairly compact compared to everything else. I've sprawled it out. I could compress this like crazy. I could put both of the blenders in a single 4x4 area. I could put these assemblers in a 4x4 area easily. Certainly these two manufacturers, I know how to put those in a 4x4 area. So this could be very, very compact. I'm going to leave it out on top. Given that it's going to be radioactive, I want to be able to see everything so I can diagnose any problems that prevent it from actually making progress. So not as sprawling as this, but still pretty sprawling. The other half is the nuclear power. So let's see here. What can I look at really quick before we call it a recording. This is Y, DD2Y. Need to show it. So this is really simple. We've got 2 manufacturers making uranium cells, followed by 2 manufacturers making fuel units. And there will be 7 total ingredients coming in. I can either make that as a stack of 2 doing one, a stack of 2 doing the other, and flow things through that way. Or I can do a stack that is one of each and do 2 of those. Well, if it's a stack that does one of each, then I have to get 7 inputs into one blueprint. And I can do that, but it's a little awkward. So what we'll do is we'll place down the blueprint. We already have the pair of manufacturers with the same inputs and the merged outputs. We'll put one down for the infused cell, and the next thing we'll put down one for the fuel units, and that'll just connect up. It's mostly an exercise for the reader at that point. So I think we're ready to go. And now this is just a matter of the rather long process of putting things down and connecting them up, because we're not going to be making use of these blueprints. Let's clear the designers, get rid of them. And the sun is rising. There. And we have our thing there. What I'm going to do, the method that I use for doing this is I will look at this and I will build the second one slightly better, and I'll erase the first. I'll look at the second one and think, what can I do better? And I'll build the next one slightly better, and I'll compare them. So each step, I'm going to be keeping a reference and building a new one. And over the long run, I'm going to have to also cross-check that I'm still, got everything going. For instance, I don't want to forget to set a recipe or put in power shards or hit the overclocks. But that's all I really wanted to record. And this is somewhat shorter than my long ones, but not as short as I thought. I figured it'd be 10 minutes. It was half an hour. That's good. So let's call that a recording. And when I come back, I will have the nuclear waste reprocessing area populated and set up and powered and programmed and overclocked and all of that.